Greetings everyone, let us now proceed to arithmetic series. Now in this video, we will define an arithmetic series. Take a look at an example and then try to derive a formula for the summation of the first n terms of a particular arithmetic sequence. Okay, so let's start. Now an arithmetic series is the sum of the terms of an arithmetic sequence. Okay, so we've already discussed arithmetic sequences. So the difference between a series and a sequence, as we know, is that series is the summation of the terms of a sequence. Okay, so this is basically the summation of the terms of an arithmetic sequence. Let's take a look at an example. So find the sum of the first 5 terms of the sequence defined by an is equal to 2n minus 1. Okay, so our general term here is an minus 2n minus 1, and we can denote our arithmetic series as S5 because this is the first 5 terms is equal to, so we will use the summation notation, I is equal to 1, and then our upper limit is 5 of 2n minus 1. Okay, so if we expand this, what do we get? Let's start with 1. 2 times 1 minus 1. Okay, and we add that to the second term, 2 times 2 minus 1, and then third term, 2 times 3 minus 1. So this is minus 1, and then plus 2 times 4 minus 1, and then plus 2 times 5 minus 1. Okay, so there you have it. If we add all of these up, so let's say this will be equal to, so we're running out of space, so let's just bear with me here. So 2 times 1 minus 1, you get 1 plus 3 plus 5 plus 7 and then plus 9. If we add all that up, you will get, let's see, 25, I guess. Yep, so 25. So this is our arithmetic series. So S5, denoted by S5. Okay, so that's basically it. Now the question arises, can we get the summation of all of the first n terms? Let's say if we were given an n of about 100 plus or 1,000, so it will be very tedious if you do this manually, if you add all the terms. So let's try to find a formula that lets us get those that particular nth term so very easily. Okay, so we have here at derivation. Okay, so generally our Sn, our arithmetic series, is equal to a1 is the first term, so our first term a1 plus a1 plus d, right? a1 plus our constant difference here d, constant term d, and then a1 plus 2d, and then up until you get to an, right? So this is a general representation of an arithmetic series. Now what if we write it the other way around? Okay, we can also write it the other way around. If we start with an, so what will we get? So we will get this, Sn is equal to an plus an, in this case minus d, and then plus an minus 2d plus all the way to a1. Okay, so if you think about it carefully, these two statements are actually equal. Okay, they add up to the same sum, right? So even though they are reversed in sequence, but at the end of the day, the summation is the same. Okay, so if we add these two expressions together, let's say we will get Sn plus Sn, so is equal to Na1 plus Nan. So why is this Na1 plus Nan? So let's go back a little bit. So see here, if you add if you add these two right hand sides, you can see here that D and the D here will cancel. The 2D and also the 2D here will cancel, and so on, the 3D, 4D, until you get to AN and A1. So they will all cancel out. So what are we left with? We are then left with A1 here, A1, A1, till you get to AN, and then AN, AN, AN. So how many A1 do we get? We get n A1s and also n ANs, right? So that is basically what we have here. So n A1 plus n AN. So we can then simplify this as 2 Sn is equal to n, if we factor out n, A1 plus AN. Okay? Then Sn is equal to n times A1 plus AN all over 2. Okay, so we now have a formula. Okay, now that we have our formula, let us now apply it. So let's go back to our favorite example. We have here the arithmetic sequence 1, 3, 5, 7, and 9. Okay, and so on. Okay, so let's say we want to find the summation of the first 100 terms of this sequence. Okay, if we take a look at our formula, our n will be 100, right? Because we want to find the first 100, the summation of the first 100 terms. Our a1 will be 1, right? We already have it here. However, we do not have our an, right? We do not have yet our an. So what do? We calculate it using the formula that we learned in the previous section of this lesson, all about arithmetic sequences. Okay, so what is the general term for this? So an, we know that an is equal to a1 plus n minus 1 times d. Okay, what is our d for this particular sequence? Our d here is 2, right? So we can write an is equal to a1 plus n minus 1 times 2. So let's now find our a100. We will get 1 plus n minus 1, that is 100 minus 1 times 2. Okay, so a100 is equal to 1 plus 99 times 2. That will be 198, right? So our A100 will be 199. So now that we have our A100, AN is equal to A100 is equal to 199, we can now apply our formula. Okay, so S100 is equal to N times A1 plus AN all over 2. So for S100, our n is 100, so you get 100 multiplied by our A1 is 1. Our A100 in this case is 199 and over 2. So what do we have? 100 multiplied by 200 all over 2. We will get, what do we get? 100 times 200, you will get 20,000 divided by 2, you will get 10,000. Okay, so this is our S100. Okay, so thank you for watching this video, and I hope you learned something, and I will see you in the next videos.